Welcome to ZKast, everybody. I'm Zeus Caraval from ZK Research, and I'm here for another one of my thought leadership interviews. This is where I interview interesting people from around the industry, and we talk about hot topics. Before I get started, though, I do want to thank my media partner, eWeek. This is part of the eWeek eSpeak series, so thanks very much for having these resident on that site. Now, today I'm talking to Chuck Lukaszewski, VP and Wireless CTO at Aruba. I think technically your PR team always wants me to say an HPE company, so I'll throw that in there. Yeah. Chuck, why don't you say hello to everybody and just give us a little sense about what you do. And I understand the wireless CTO is kind of new for you, right?
Yeah, thanks. It is. I was promoted in that role this year. I've been working in the CTO team for 7 or 8 years now. But I'm basically responsible for 4 things. We do kind of next gen product strategy, and I know we're going to talk about Wi-Fi 6E and cellular convergence. So I incubate new technologies in that space, and I do spectrum policy, which is getting more spectrum. So that's relevant to the 6 gigahertz topic. And we do some basic R&D, and then I own the team that does standards, so like Wi-Fi Alliance and IEEE and other organizations like that.
Oh, very cool. Now you spoiled the surprise for everybody. There's a spoiler alert there when you said Wi-Fi. But I guess if we're talking to Aruba, we're going to be talking Wi-Fi. I did notice you recently announced just after your Atmosphere event your Wi-Fi 6E product. But before we get into the product itself, tell us a little bit about what exactly Wi-Fi 6E is. We already had Wi-Fi 6, how it's progressed, how it came about, just a bit of the history here and exactly what it is.
Yeah, absolutely. So from a technology perspective, Wi-Fi 6E it's the same technology as Wi-Fi 6, but from a spectrum perspective, it's different. So we've been working for 5 years now with industry peers to try to get the new spectrum opened up for Wi-Fi, because it's been actually, believe it or not, almost 20 years since Wi-Fi had its last spectrum allocation. That was in 2003 for the middle of the 5 gigahertz band. And we've not had any spectrum allocation since that time. And of course, we're different from the cellular community, right? We don't pay for spectrum. We're dependent on regulators deciding that unlicensed spectrum has economic value, social value, and so on. So we began a process about 5 years ago of saying, hey, the 5 gigahertz band is really maxed out, right? We can see the writing on the wall, and and there are things that the technology is capable of that we can't really do in 5 gigahertz. For example, the really wide channels, like the 80 megahertz channels, the 160 megahertz channels, which is what you need in order to do at least a gigabit per second. We really can't do in 5 gigahertz because there's not enough spectrum. And so we're really gratified that regulators around the world have moved really aggressively, starting here in the US last year, to open up the 6 gigahertz band. And so Wi-Fi 6E is Wi-Fi 6 for the 6 gigahertz band.
So does it, and you're right, I have seen studies on the importance of Wi-Fi in people's lives. I think people now say they'd rather have good Wi-Fi than a car and things like that. So,
coffee.
Yeah. And so does is the benefit we get from 6E that it's just new spectrum? Is it faster? Because Wi-Fi 6 promises a pretty big band. So exactly how will companies benefit from 6E versus 6?
Yeah, so this is really important. So there's a number of different benefits, and it kind of depends. It's like Wi-Fi, right? It depends on what you're using Wi-Fi for. There are hundreds and hundreds of different use cases for it. But broadly speaking, so first of all, it's as I said a minute ago, we're able to do these really wide channels, which means gigabit and multi-gigabit speeds. And so there's a lot of use cases that we're not able to do as well or at all today. For example, I know augmented reality, extended reality get a lot of play today, but you're looking at anywhere between a 50 megabit per second to 100 megabit per second continuous stream of data. And in the case of AR, right, or XR, there's a round trip latency requirement that is very, very tight. It's even tighter than voice traffic. And so the really wide channels allow us to do that kind of a use case in a way that we really can't do as well in 6 gigahertz. And you think about airports, right? We're starting to travel again. There's a lot of sort of high bandwidth applications there. So that's one category of applications. Another that, the US and Canada are both permitting what's called a standard power operation. And that means we can use the 6 gigahertz band outdoors. And if you think about it, we've outdoors, we've had DFS constraints in the 5 gigahertz band, right? We haven't had access to maybe all of the channels. And there's a ton of applications coming. If you look at mining and manufacturing, intermodal transportation, there's a lot of automated vehicle, sort of use cases. Caterpillar is demoing dump trucks as AGVs essentially that have Wi-Fi APs on them they're using for command and control. Interesting example in container terminals. People probably don't know this, but containers actually can get lost at sea. You actually pay more based on where you are in the ship. The further you are on the inside, the more expensive the seat, if you will. And containers get damaged when they get loaded and unloaded and stored and what have you. And so the cranes that pick up and drop off these containers from the ships and then moving them around the yards are continuously filming and videoing these containers for insurance purposes, right? So you have these high definition video streams of these containers from all these cranes, and that just burns up a lot of bandwidth. And so, there are just a ton of applications along this line that this new spectrum is going to make possible.
That's cool. So now, but from what I understand, because it is 6 gigahertz, and I've got this device obviously, which is 2.4 and 5, it's not backwards compatible. So how companies deploy these? I assume they'll deploy them together, but where are they going to use? Will they salt and pepper them, or like what would the deployment model be like in a typical enterprise?
Yeah, wonderful question. So first of all, from just an AP density perspective, you're going to deploy at the same densities you're deploying in 5 gigahertz today. The power limits that have been approved by the regulators in 6 gigahertz align very nicely with what we have in 5 gigahertz and 2.4. So you're not going to have to pull more cable to do 6 gigahertz. Whatever density you're using now will be fine. In terms of what you're going to deploy, so broadly speaking, I think mostly you're going to see what we call tri-band AP. So those are 2.4 and 5 gigahertz with the addition of a 6 gigahertz radio in the housing. And so we announced a product, just very recently. I think we're the first enterprise vendor to announce a 6 gigahertz AP, and that is a tri-band 2x2 access points. So 3 radios, each radio does 2 spatial streams, and a customer would deploy those when they get when they're up for a refresh, and they can literally dismount maybe the dual band APs they've been used to deploying, and they can substitute the tri-band APs no problem, and the system will manage roaming between the different bands.
Now, Chuck, I know you just mentioned this, that you launched a new product. Can you do a little bit of double click on what you just announced? As you said, you were the first enterprise vendor to launch a tri-band AP, and just go through what the product is and some specs on it.
Yeah, absolutely. So again, it's a tri-band unit, so it's 3 radios. As I mentioned, it's 2 spatial streams on each of the radios. In the 6 gigahertz band, it will do up to 160 megahertz wide channels, which will support multi-gigabit applications. We'll do 80 megahertz channels in the 5 gigahertz band, and then the usual in the 2.4. So all told, if you add up the capacity of the 3 radios, the top line, the throughput, if all 3 were active, is 3.9 gigabits per second. And we actually did a demonstration recently online where we showed 2.3 gigabits per second, I think it was. We had 3 clients, 1 on each radio, doing a full buffer test. And we were pumping 2.3 gigabits per second of actual throughput through the unit, and that gets to the, okay, so how does it connect to the network? So this product includes dual 2.5 gigabit copper smart rate ports as well, and so you can combine those, of course, if you have two cables for up to 5 gigabits per second.
Yeah, well, it's funny because we've been hearing about gigabit Wi-Fi forever, but we've never really had it, right? We haven't close to it, but this actually takes us well over that bridge. So now this decision of do I go wired performance, wireless for mobility goes away. We just go wireless everywhere. But now that we can do that, and we're going to see more Wi-Fi devices. In fact, I think with the whole hybrid work scenario coming, we're going to see an explosion of IoT devices and things. It gets much harder to manage, right? And I know Aruba has a product called Central, which is an AI-based management tool.
Yeah.
How important does that become in this world that's become predominantly wireless?
Yeah, so I mean, this Central is it's the nexus of everything that we're doing, from a management perspective. And I should add, you mentioned IoT, and I should have also mentioned that the new APs, the 600 family, just like the current Wi-Fi 6 products, include 2 IoT radios. So there's a Bluetooth, latest generation Bluetooth radio, and there's a Zigbee compatible radio as well. So we support a couple different IoT modes. And these radios can be configured and managed in Central by an administrator. And Central has come a really long way over the last few years. We've got incredible feature velocity to it. And I run my whole house. I've got 30 some odd wireless devices and about 24 wired devices here, and I'm managing all of it with Central. Including the policy, the wired and wireless policy applications on it. And one of the sets of new features that we've been introducing, we've heard loud and clear from our customers that they have to do more and more with less and less, right? That's just the world that we live in. And so things, automation, machine learning tools are critically important, and we've introduced a number of new capabilities around AI ops and the self-learning, self-healing capabilities into Central that continue to make that management experience a lot industry leading in terms of the workload on administrators.
Well, I'm guessing you get a pretty good discount on Aruba stuff, so I'm not surprised you're in Central Home. I'm going to pivot gears here a little bit. We're in this alphabet soup of Wi-Fi 6 and 6E. There's also this other wireless out in the horizon called 5G. And I'm sure everybody has seen Lily from AT&T on TV talking about, the benefits of 5G. But there's actually 2 deployment models for 5G. This is a service provider model, i.e. your Verizon, Vodafone, AT&T type. And then there's there's more and more on-prem vendors that are making CBRS solutions. So how do those get used, and when an enterprise thinks about 5G, what should they be thinking of?
Yeah, so I appreciate you asking the question, because it's still, to this day, it's a topic that I'm regularly speaking with CIOs and senior IT leaders about, how to think about this problem and how to where do these fit right in the arsenal of IT tools. So let me just first start by describing kind of our point of view about all of these technologies generally, and then I'll answer your question about sort of 5G specifically. So a lot of people have seen me say publicly that it's an all of the above strategy, in the sense that these are all different forms of what we would call access networks, right? And there's a term of art in the cellular world called a RAN, which is a radio access network. And we've been selling RANs for years, right? The product that we were just talking about, right, has 3 RANs in it, right? It has a Wi-Fi RAN, a Bluetooth RAN, and a Zigbee RAN. Those are all access networks providing service to endpoints, to devices, right, that connect them to a network. And so in that context, 5G and even 4G LTE, those are just additional kinds of RANs, if you will. And it is absolutely, and if you think about, we have certain categories of customers. So a hospital, for example, that might have a special purpose RAN. So hospitals have a thing called wireless medical telemetry, WMTS, which is a licensed band used for telemetry. So, the fact is that enterprises already use a lot of different kinds of access networks to solve different kinds of problems. And our philosophy is that these are all different tools in the toolbox for an IT architect to use, based on a particular set of business requirements and conditions. So then to go to your question specifically about 5G, so yes, there are different consumption models for sure, and the mobile operators are deploying 5G in their macro networks. It's a little bit slow here in the U.S. for the moment because the main spectrum that's going to be targeted for 5G is in what's called the C-band, which is just being cleared right now. It's historically it's been satellite spectrum, and by this time next year it'll be vacated. And the operators will be deploying their networks in that spectrum, and that's going to give them wide channels, up to 100 megahertz wide channels. So they'll be able to have very fast speeds, and it's got pretty good propagation. The other model is, as you say, sort of the on-prem model, and so we announced a solution in partnership with a company called Solona in November. That is Solona is a really exciting startup in the small cell space. They're really the first new startup in years, and they're focused specifically on what's called CBRS in the US. So CBRS is not a technology, so it's not 5G or 4G. It's a spectrum band that sits in the middle of the 3 gigahertz range. You can run either technology. Right now, the products we have are 4G. The 5G products will be available soon. And what's so interesting about that product is that for really the first time, it's really easy to deploy. You don't have to be a cellular expert. You don't have to, as an IT person, you don't need to know any vocabulary about cellular networks or engineering or any of those topics. And it's really built by enterprise networking people for enterprise networking people. It just happens to use cellular technology.
Yeah, in fact, I recently did a ZKast with Rajiv Shah, the CEO of Solona, and he talked about that if you can deploy Wi-Fi, you can deploy Solona CBRS, and so I guess that's your product now. Now, there's other equipment manufacturers that make on-prem 5G. For instance, a Nokia and Ericsson, even a Huawei. Not that we're deployed over here, but what's different about the way they deploy 5G and the way Solona does?
So there's a number of differences. So let's basically the three that I would talk about are sort of the let's just say complexity. We'll talk about cost, and then talk about network integration into the network core. So from a complexity perspective, the way that cellular equipment has historically been purchased and deployed is that it's bought by mobile operators who have experienced engineers that understand how all these different pieces go together, and it's a little bit like building a kit car or a kit airplane. So you buy your radios from vendor A, and then you need a cellular core network, which is complicated stuff. So you buy that from vendor B. And then if you're going to use CBRS in the US, then you have to have what's called a SAS, right? A spectrum access system, to give you permission to use the spectrum. And so you can buy the SAS from vendor C, and then you've got to stitch all of those pieces together and prove it out and do interoperability testing. So that's the mode that the operators have worked in. And that's what the companies you mentioned are used to doing. Of course, that doesn't work for the enterprise. The enterprise is barely resourced to keep up with what's on their plate today. So Solona has put it all together in one package. You don't need to know, again, any of this terminology. You don't need to duct tape different pieces together. It's a easy to deploy end-to-end, a single end-to-end experience that has the radio, the core, the SIMs, the SIM cards, the management plane, all in one package. So that's the first difference. The second is cost. And of course, those vendors that you mentioned are selling to mobile operators, and they're used to paying. They're really engineered for the macro network, and so there are technical requirements about self-interference on towers and other things that drive up the price point of that equipment. You don't need those features when you go indoors, right? And you're protected from the macro network. And so Soluna can build equipment a lot more affordably than, it's a lot more like Wi-Fi than it is traditional cellular equipment. And then finally, from I said core network integration. So the cellular community, if you think about the cellular networks, they're really large monolithic single tenant networks, right? That's what, pick an operator, right? AT&T, Verizon, they're all sort of similar. They control the entire network, the core, the distribution layer, and so on. And then they carry traffic from different subscribers over that network. And so it's not very complicated from a layer 3 or layer 4 perspective in terms of plugging in the end users. But when you go into an enterprise, you've talked about this for years, right? The ability to do policy and very sophisticated micro segmentation, right? To be able to separate IoT data flows from administrators, right, who may be doing things on a system, or from end users in different kinds of enterprise roles. To be able to separate that traffic at a very granular level is a basic requirement of enterprises. And so the Soluna product has some really unique features there that, frankly, you would not find in a traditional cellular equipment, because it's just not a requirement in what they do.
Yeah, I think just built for enterprise, built for service provider. I just have a couple more questions here. One is, we've all heard this before, and I've been hearing this for the last 10 years. Cellular is going to kill Wi-Fi, right? I've read this all over the place in a lot of media publications. Will 5G kill Wi-Fi? Or it didn't happen with 4G, didn't happen with 3G. You're still a pretty profitable company from what I've seen selling Wi-Fi. So what happens with 5G and Wi-Fi?
Yeah. So, I think people who make statements like that are just looking for headlines, right? Or clickbait. The reality is, 5G needs Wi-Fi, and Wi-Fi, I don't know if I'd say it needs 5G, but each of them is going to be more successful with the other. So what do I mean by that? So first of all, if you think about 5G, right, the principal use cases we hear about all the time, most of them have Wi-Fi on the end, right? So, if I'm tethering my phone, right, and I have a gigabit connection to the tower, and I want to do AR, VR, or I want to watch a video, movie, right, 4K video from my phone, cast it to my TV, I'm using Wi-Fi as the last meter, right, for that connection. Same thing with millimeter wave. Right, so Verizon and others right now are selling millimeter wave 5G services for backhaul, but that's just to the building point of entry, right? Within the building, it's being distributed as Wi-Fi signal. So you can sort of go on down the list of the 5G use cases where Wi-Fi is an intrinsic part of actually realizing the value of the use case, and of course offload. You mentioned 3G and 4G. And it is, even with all the new spectrum that the operators have purchased, the amount of load they're expecting to carry, right? Analysts have estimated that that load is actually going to drive more traffic over Wi-Fi. They're estimating it's going to go from a little over 50% now to well over 60% of bytes that come off a mobile device are going to be carried on Wi-Fi, because that's how you make the economics work. If you're an operator, you need to carry as much traffic as you can on the lowest cost medium, and that is Wi-Fi.
All right. And thanks for spending all this time. They just have one more question for you, though. So if I'm watching this, I've heard a lot of, again, alphabet soup. I've heard 6.6, 6E, 5G. If I'm planning out my next generation, wireless strategy, tell me how I should think about using those three all together and, having all my users have a great experience.
Yeah, absolutely. So on the Wi-Fi front, let's start there. If you're in a country that is allowing 6 gigahertz, and you are, either approaching the end of your current lifespan for the equipment you've got on the ceiling now, or maybe you're a little more than halfway through it, you should be thinking seriously about 6 gigahertz enabled equipment in your next refresh. And there's really there's not a good argument for not deploying 6 gigahertz if it's available, because you're future proofing your network, even though it's going to take a couple of years for the 6 gigahertz clients to come into your workplace. There are going to be some from the beginning, and upgrades happen when upgrades happen, right? Companies tend to be on a specific financial cycle for that. So you want to get the most you can when it's time to do your upgrade. So absolutely, right. If you're in a country that allows 6G operation, you want to buy 6 gigahertz APs, no question about it. On the cellular front, if you are if you have large outdoor operations and you don't have a cost-effective way to provide outdoor coverage, and you want to be able to ideally kind of roam between Wi-Fi indoors and maybe cellular outdoors, that's a good reason to look at CBRS. We're seeing a lot of uptake for that type of thing. If you're a hospital, or if you're an airport, or some a lot of the DAS systems that are out there are pretty young. Actually, they've been deployed in the last 3 or 4 or 5 years to do 4G LTE, and they have a lot of years of life on them. And there's no necessarily justification to go back and rip all that out just to put in 5G. So if you're a customer that has a DAS, you want to drop in a 5G layer using CBRS, keep the DAS you've got, and just use this as a cost-effective way to sort of bridge the gap. That's a reason to come talk to us about CBRS.
All right. Well, thanks, Jack. There's a lot of good information there. From the voice of Chuck Lukaszewski. You'll use all of them together, and I think that is correct. I think we, as analysts, even sometimes we try and paint these pictures where one technology is going to eradicate another one that never really happens. So, anyways, thanks for your time today. And if you're watching this, don't forget to click to subscribe. I'm ZKast from ZK Research, and on behalf of Chuck, thanks for watching.